I have the pleasure of welcoming Karl-Heinz Fritz from Cicor Group. He is actually the VP of Technology, and he will talk about embedded components in plastic parts, including the subsequent connection using aerosol jet printing. Now we are perfect.
Sure.
Karl-Heinz, the stage is yours.
Thank you very much, Christoph. My name is Karl-Heinz Fritz. I'm Vice President for Technology at the Cicor Group. And I have the pleasure to talk to you about embedding of plastic or components in plastic with the subsequent connection using aerosol jet printing. Start with a few words about Cicor. Cicor is a Swiss headquartered full service provider in the electronic solutions industry. So we are supporting our customers from the research and development to manufacturing and supply chain management. We are a Swiss leader in customer specific development of solutions, high-tech components and electronic devices. We are a strongly growing company with currently about 2,500 employees at 15 operating sites. We've been pioneering in Swiss microelectronics since 1966, and we are listed at the Swiss Stock Exchange. Since 4 years, we've been dealing with printed electronics using aerosol jet printing technology from Optomec. We currently are running a development lab at our headquarters here in Switzerland, and will this summer open a second lab in Singapore, which then will be a cooperation to roll that out to production. Aerosol jet printing, for the ones who are not familiar with this technology, is a very versatile technology, and we can literally print all materials that have a viscosity between 1 and 1,000 centipars. We can print materials with different functionalities: conductive nanoparticle inks, non-metallic conductive inks, dielectrics, functional inks, and even bioreactive materials. On the right picture, you see a schematic of how this process works and what makes it different from a standard inkjet technology. So we are creating an aerosol that consists of droplets in a diameter range between 1 and 5 micrometers. This aerosol is then transferred to the print head, where it is embedded in a sheath gas, focusing the ink beam or the inkjet, which is enabling us to have a variable standoff to the surface of the substrate we are printing on, while still keeping consistent printing results. After creating a toolpath, which is just shown in the picture on the bottom right, this is transferred to the printing equipment. In the center, you see the printing equipment we are using. This is a 5-axis equipment that is enabling us to print literally on all kinds of shapes of structures, and has all the capabilities this technology has to offer. Another very important part is then the curing of the inks after printing them, because if we are working with nanoparticles, we have to do a thermal curing of the nanoparticles in order to remove the functional coating of the particles, and then initiate a sintering process of the metal particles, forming a conductive path. Structure sizes we can print up between 10 microns and several millimeters in one pass. Thickness is typically between a few hundred nanometers to several tens of microns. We can also do multiple printing passes. The main content of this presentation, we have combined a lot of the different capabilities the Cicor Group has within its portfolio. First thing was that we were embedding an NFC driver chip in polycarbonate plastic using injection molding, where the component was placed inside the injection molding tool. We can do this with different kinds of plastics, depending on our